Welcome back to Dundell's Cyberspace, everyone. I'm your host, Eric Dundell, and today we're diving headfirst into a topic that combines nostalgia, cutting-edge software, and a bit of digital archaeology, video game emulators. For many of us, it's about revisiting those cherished childhood games that are hard to play on modern hardware. But what exactly is an emulator? And what are the best ones out there, you know? To guide us through this intricate cyberspace, we have the brilliant Dr. Evelyn Reed. Dr. Reed, thank you so much for joining us.
Thanks for having me, Eric. It's always a pleasure to discuss game preservation and the fascinating world of emulation.
Let's start with the absolute basics for our listeners who might be completely new to this. When we talk about a video game emulator, what are we actually referring to? Can you explain what it means in simple terms?
Absolutely. At its core, a video game emulator is a piece of software that allows one computer system, your personal computer, your phone, or even a tiny device like a Raspberry Pi, to mimic the hardware and software environment of another, usually older, game console. Think of it like a digital disguise. Your computer pretends to be a PlayStation 2, for example, enabling you to run games designed for that original console on your current device. It's essentially a way to digitally preserve gaming history and play those classics without needing the original bulky hardware.
That's a great analogy, a digital disguise. So it's about making one machine act like another. Now, you mentioned different consoles. From what we've seen, it seems like there isn't just one emulator. What are the different kinds of emulators out there, especially categorized by the consoles they emulate?
That's right, Eric. It's a vast ecosystem. You'll find a wide spectrum, often tailored to specific console generations or even individual systems. For older systems, we have very mature and often near-perfect emulators. For example, for the Super Nintendo SNES, 9X is incredibly popular and performs flawlessly. For Nintendo 64, Project 64 is a powerhouse, running games smoothly, often at over 50 frames per second. And for the original PlayStation, DuckStation or ePSXe are fantastic choices offering great compatibility. Moving into the 2000s, we see more complexity. For the PlayStation 2, PPSSPP is widely considered the ultimate solution for PlayStation 2 emulation. It's been in development for nearly 20 years and can run most commercial playable speeds, often with enhanced visuals beyond the original console. For the PlayStation Portable, PPSSPP is incredibly robust and performs very smoothly because the PlayStation Portable's architecture is a bit simpler to emulate.
And for the Nintendo GameCube and Wii, Dolphin Emulator is a shining example. It's constantly being updated and offers remarkable accuracy and performance.
Wow, that's already a lot of ground covered. You mentioned PPSSPP for PlayStation 2. My understanding is that the PlayStation 2 is quite complex. What makes PPSSPP so good, and how does it handle that complexity? Does it use a lot of specific features like those plugins I've heard about?
That's a perceptive question, Eric. The PlayStation 2's Emotion Engine central processing unit with its dual instruction sets and vector units was notoriously intricate. PPSSPP tackles this with a highly sophisticated plug-in architecture. This means different parts of the emulator, graphics, sound, input, can be handled by separate modules. For instance, GSDX is the primary graphics plugin for Windows, while SPU2X handles audio. This modularity allows for specialized optimization and improvements to individual components. It also employs recompilers that translate the PlayStation 2's specific machine code into something your personal computer's x86 processor can understand efficiently. And yes, it's an open source project, constantly being refined, which really speaks to the dedication of its developers.
That's fascinating. So it breaks down the complex system into manageable chunks. You also mentioned PPSSPP for the PlayStation Portable as being smoother. What's the fundamental difference in approach there compared to something like PPSXe? Is it because the PlayStation Portable was a handheld?
Exactly. The PlayStation Portable, while powerful for its time, had a less complex architecture than the PlayStation 2. PPSSPP is generally described as a high-level emulator. It focuses on simulating the functions of the hardware rather than every tiny detail. This just-in-time recompiler approach is incredibly efficient. PPSXe, on the other hand, operates more as a low-level emulator for the PlayStation 2's more intricate design, mimicking individual components more closely. The higher complexity of the PlayStation 2 means its emulation is inherently more resource-intensive, while PPSSPP can often run PlayStation Portable games at 10 times native resolution with ease.
That distinction between high-level and low-level emulation is really helpful. You mentioned high-level emulation being more performant on less powerful systems. Can you break down what that means for our listeners? And are there other types of emulation that aren't quite the same, like virtual machines or wine?
Great question, Eric. That's a crucial point in understanding how emulators work. High-level emulation, or HLE, focuses on simulating the behavior or functions of the original hardware rather than recreating every single circuit. It's like knowing what a button on a complex machine is supposed to, and then just making your system do that action, without bothering to build the button itself. This is generally less accurate in mimicking exact hardware quirks, but far more performant, allowing older games to run well on less powerful modern devices. Low-level emulation, or LLE, conversely tries to mimic the original hardware down to every signal and component. It's incredibly accurate, almost like building a digital twin of the original console. But it demands significantly more processing power from your host computer. For instance, an LLE for a Super Nintendo Entertainment System might be so accurate it demands a processor 100 times faster than the original Super Nintendo Entertainment System itself. As for other related technologies, virtual machines, like VirtualBox, are technically a form of emulation, but typically they create an isolated environment to run an entire operating system, like Windows, on your current system, often on the same processor architecture. For example, an x86 VM on an x86 personal computer. They might emulate some hardware for compatibility, but the goal is usually general computing, not specific console games. Wine, which famously stands for Wine is not an emulator, is a compatibility layer. It translates Windows system calls into Linux-compatible ones, allowing Windows programs to run directly on Linux without simulating a whole Windows operating system or hardware. It's about bridging software differences, not hardware differences. So while they all help run different software, their approaches and purposes vary significantly from console emulation.
That makes so much more sense. Thank you for clarifying that distinction. So with all these different emulators, what about the operating systems? What operating systems can typically run these emulators, and can phones handle them? Or is it mostly desktop personal computers?
That's where the versatility of modern emulation really shines, Eric. Many emulators are incredibly cross-platform. For instance, PPSSPP officially supports Windows and Linux, with unofficial support for macOS, and where the Dolphin emulator for GameCube and Wii runs on Windows, macOS, Linux, and even has official Android builds. PPSSPP, the PlayStation Portable emulator, is available on Android, Windows, macOS, Linux, and iOS, including App Store versions. And then you have something like RetroArch, which isn't an emulator itself, but a unified front end that hosts various cores, each being an emulator for a specific console. RetroArch is remarkably versatile, running on Windows, Mac OS, Linux, iPhone, iPad, tvOS, Raspberry Pi, and even directly on many hacked game consoles like PlayStation 2, PlayStation 3, PlayStation Portable, PlayStation Vita, Wii U, 2DS, 3DS, and Switch. It even has dedicated community versions like Laka for Raspberry Pi.
Wow. So RetroArch is like the Swiss Army knife of emulation. And speaking of phones, it sounds like mobile devices can definitely run them. How well do they run? Is there a noticeable performance gap between a phone and a personal computer?
You hit on a key point, Eric. Yes, phones absolutely can run many emulators. Modern smartphone processors are incredibly powerful, often capable of handling everything from NES, Super Nintendo Entertainment System, Sega Genesis games flawlessly, right up to PlayStation 1, PlayStation Portable, Nintendo DS, and even GameCube or Wii titles, mostly depending on the phone's chip. There's also ePSXe, which is a new Android emulator for PlayStation 2, is showing impressive performance on mobile devices. However, there can be a noticeable performance gap compared to a high-end personal computer, especially for more demanding systems. And critically, while the raw power is there, the user experience on a phone can be challenging. Playing console-style games with on-screen touch controls is often frustrating, and while you can connect Bluetooth controllers, it's not always as seamless as a dedicated gaming setup. Devices like the Steam Deck, which are essentially portable personal computers running Linux, bridge that gap by offering PC-level emulation in a handheld form factor with integrated physical controls. And they're doing phenomenal things with tools like EmuDeck to simplify setup.
That's a great point about the user experience. Raw power isn't everything if the controls are a mess. So let's talk about getting started. How hard are these emulators to set up for an average user? Is it a quick install, or are we looking at a weekend project?
It really depends on which path you choose, Eric. Retro mini consoles like the Super Nintendo Entertainment System Classic are the easiest. True plug and play. You just plug them in and the games are there. Even adding more games to them if you acquire the ROM is a surprisingly simple process. Personal computer emulators can vary. Downloading and installing them is usually straightforward. However, configuring them, especially getting controllers set up perfectly, or tweaking graphical settings for optimal performance per game, can be time-consuming. Some, like PPSSPP, also legally require you to dump the BIOS time your own physical console, which can be a challenging multi-step process for a novice. Raspberry Pi setups, often with RetroPie or Laka, usually require a beginner to intermediate technical know-how. It's not rocket science, but you'll do some command line work and a fair bit of tweaking. But then there are tools like EmuDeck for the Steam Deck, which have made the setup trivially easy, even for Linux novices. It automates emulator installation, controller configuration, and integrates games directly into your Steam library. So the landscape is definitely becoming more user-friendly.
That's encouraging that it's getting easier, especially for the Steam Deck. You've mentioned a few specific emulator projects. This brings up the next question. Are there certain emulator projects that are widely considered better than others in terms of quality, performance, or accuracy? Or is it all pretty much the same?
Oh, there are absolutely significant differences, Eric. It's definitely not all the same, and the community has strong preferences. Some projects, like Dolphin for GameCube and Wii, strive for a careful balance. They aren't cycle accurate in the sense of mimicking every single internal clock cycle, because that would be incredibly performance intensive. Instead, they prioritize an experience that feels accurate and plays well, often using smart estimations for timings. Other projects, like the Super Nintendo Entertainment System emulator Higgin, prioritize extreme accuracy, even if it demands significantly more powerful hardware. Then there's the topic on dedicated versus multi-system. Dedicated emulators for a single console, like PPSSPP for PlayStation 2 or Dolphin, often achieve very high levels of polish and compatibility due to their singular focus. They are the ultimate solution for their respective systems. Multi-system front-ends like RetroArch are better in their versatility, offering a consistent interface across dozens of consoles by integrating various cores, which are the actual emulators. RetroArch is incredibly active, with new cores like LRPS2, a heavily modified PPSSPP version, being integrated and features like Blurbuster's CRT shader for enhanced motion clarity. Then there's the community. Projects that have been around for a long time, like Dolphin and PPSSPP, often have a very active development community, extensive wikis, and years of bug fixes, leading to superior compatibility and stability. Their stable releases, even after years, incorporate massive improvements.
So, it's not just about getting the game to run, but how it runs, and how much effort the developers put in for accuracy and features. That's really helpful. Now, for the cutting edge, the consoles that were considered unemulatable just a few years ago. What's the overall recommendation for hardware required to run higher-end emulators like those for the PlayStation 3 or Nintendo Switch? This seems like where the real heavy lifting happens.
You are absolutely right, Eric. This is where the rubber truly meets the road and the hardware demands skyrocket. While the performance of emulators for systems like PlayStation 3 and Nintendo Switch has come leaps and bounds, they still require significantly more robust hardware than what's needed for older consoles. For PlayStation 3 emulation, primarily with RPCS3 or Nintendo Switch emulation, with projects like Yuzu and Ryojinx before their recent legal challenges, you are looking at some of the following. A powerful, modern, multi-core central processing unit with high single-thread performance. Emulation is incredibly CPU-intensive. While multi-core CPUs are common, many emulators still heavily rely on strong single-thread performance due to the sequential nature of how console instructions are processed. Intel CPUs, particularly their higher-end Core i7 and i9 models with high instructions per cycle, or IPC, often excel here. For instance, testing with RPCS3 showed a 12th generation Intel Core i9-12900K, even with AVX 512 enabled, making a noticeable difference in performance. We're talking about passmark single-thread scores of 2100 or higher. Then there's the need for a dedicated, modern graphics processing unit with substantial video random access memory. Integrated graphics, even on a modern AMD APU, like the Ryzen 5 3400G, are generally insufficient for demanding PlayStation 3 or Nintendo Switch emulation. You'll want a dedicated graphics card from NVIDIA or AMD. Something in the mid to high range like a GeForce GTX 1050 Ti as a bare minimum for PlayStation 2. But for PlayStation 3 or Nintendo Switch, an RTX series or AMD 6000 card is recommended, with 8GB or more of VRAM to handle resolutions and complex shaders. Then there's a substantial amount of RAM, often 16GB or more. Emulators often load large portions of game data and the emulated system's state into RAM, so more is generally better. Fast DDR4 or DDR5 RAM is ideal. In essence, you need a high-end gaming personal computer for a truly playable experience with these more modern systems. They are still pushing the boundaries of what's currently feasible in software emulation.
That's excellent advice. So, if you're planning to dive into the latest emulation frontiers, you need a powerhouse machine. Dr. Evelyn Reed, this has been an incredibly comprehensive and insightful conversation. You've really demystified the world of game emulators for us. Thank you so much for breaking all of this down.
My absolute pleasure, Eric. It's a truly exciting field, and I'm always happy to share.
Thank you for joining us. I'm Eric Dundell, and this has been Dundell Cyberspace. Until next time.